Hi, everyone. In this video, I'm going to define what is an event. So in this unit, we're going to be talking about probability, and the events, these are going to be what we are trying to find the probability of. So these are what we will try to find the probability of. And so the mathematical definition of an event is a little bit abstract, but hopefully through enough examples, we'll get a better feel for it. So for an experiment with sample size S, or not sample size, sample space S, an event E is any subset of the sample space. And so what is a subset? So a subset just means you have some set, right? The sample space, it's a collection of outcomes. And a subset is another set that's made up of only things from our original set. So a subset of S is a collection of elements or things, so of outcomes, that belong to S. And this subset, it could be anything. Can be all of S, or it could be empty and contain nothing. Okay, and for reasons that will be clear, so if the event, well, I'll say this after our example. Let's see an example. So suppose our experiment is the tried and true, roll a 6-sided die and record the result. What's the sample space? The sample space is the collection of all possible outcomes. And as we well know, all possible outcomes is 1, 2, 3, 4, 5, and 6. So what are some subsets of this? One subset, this event, is 1, 4. It just has the things 1 and 4. And this is a subset because it has 1, which is in S, and it has 4, which is in S. Another subset is 1, 2, 5, 6. Right? 1 is an S, 2 is an S, 5 is an S, 6 is an S. Another subset, well, it could just be all of S. That's also a subset, right? Everything here comes from S. We also have a special subset that might seem a little strange. This is called the empty set. And it consists of nothing. Now, it might seem a little weird to say that this is it only consists of things from S, but for various reasons that we'll see later, it's convenient to have a set like this. This is called the empty set. It's also considered a subset of S. Okay, and so why is this abstract notion of a subset, why should that be called an event? Well, often events correspond, mathematical events correspond to easily stated outcomes. Easily stated, I'll say, groups of outcomes. And so, for example, we can say the event, So an event could be even, or the event could be you roll an even number. And so what, if this is my event E, what subset of S does this correspond to? Well, we look at S and then we say, which of these numbers satisfies this statement? You roll an even number. Well, 1 is not even, so that's out. 2 is even. 3 is not even, so that's out. 4 is even. 5's not even. 6 is even. And so you roll an odd number or an even number corresponds to rolling a 2, 4, or a 6 from this sample space. And so the subset that this corresponds to is 2, 4, 6. This is our subset. Another example, you roll a number greater than 4. Well, the subset that corresponds to that consists of every number that's in here that's greater than 4. So 1 is not greater than 4. 2 is not greater than 4. 3 is not greater than 4. 4 is not greater than 4. It's equal to 4, but it's not greater. 5 is greater than 4. 6 is greater than 4. So this corresponds to the subset 5, 6. And so really an event is just a group of a collection of outcomes. One of those occurs, that means your event occurs. So if you roll a 5, that means your event occurred. You rolled a number greater than 6. And 6 is also greater than 4, so that your event occurs. And so thinking of events as subsets of the sample space S is kind of like selecting every possible outcome that means your event occurred. So for example, this subset here, 1, 4, maybe our event could have been something as simple as you roll a 1 or a 4. And so now, if our event is, quote unquote, you roll a 1 or a 4, we can go through all of these and see which one means our event occurred, which one satisfies our event. Well, 1 does, 2 does not. If you roll a 2, then you didn't roll a 2 or a 4. Or sorry, if you roll a 2, then you didn't roll a 1 or a 4. A 3, well, the 3 is not a 1 or a 4. So if you roll a 3, you didn't roll a 1 or a 4. A 4 is a 1 or a 4. A 5 is not. A 6 is not. So the only events that satisfy 1 or a 4, or the only outcomes, are 1 and 4. And those are exactly the ones that go in the subset that corresponds to this event. Okay, let's do another example. So you flip a coin and roll let's say roll a 4-sided die. So you flip a coin and roll a 4-sided die. Then let's find, so our sample space, well, you could get a 1 and you could get a heads. You could get a 2 and get a heads. You can get a 3 and get a heads. And you can get a 4 and get a heads. You can also get a 1 and get a tails, 2 tails, 3 tails, and 4 tails. And this is it. And in fact, you can use the multiplication rule for counting. to count all of the possibilities, and you see that there's only 8, and this is 8. And so let's see if we can find what's the subset that corresponds to the event. You flip heads. Okay, and so this is just all of the outcomes that satisfy. So if you if you get a 1 and a heads, did you get a heads? Yeah, you did. You didn't just get a heads, but you flipped the coin flip. So maybe I'll say to you more specifically, coin flip is heads. So if you roll a 1 and flip a heads, then that's a coin flip is heads. Similarly, if you roll a 2 and get a heads, then your coin flip was heads. If you do a 3 and get a heads, your coin flip was heads. And if you do a 4 and heads, your coin flip was heads. If you get a 1 and a tails, then that doesn't satisfy this event. This event did not occur. Similarly for these other ones. Another event could be you roll an even number. This corresponds to the subset. Well, 1 heads, this 1 is not an even number. For 2 heads, the 2 is an even number. This does not satisfy our event because this 3 is not an even number, but this 4 is. Similarly, 1 tails should not be in our event because that's not an even, 1 is not an even number. 2 tails, that is an even number. 3 tails is not an even, we did not roll an even. And 4 tails, you did roll an even. So this would be what corresponds to this event. Okay, so it can be a little abstract, but if we think about it as just our event as a subspace, this is just all of the outcomes that satisfy what we colloquially call an event. It just satisfies a specific outcome. Then it hopefully is a little clearer what's going on. That's going to be all for this video.